let us have an example. So for example 1, we have to find the solution in interval notation of the rational inequality, which is x squared plus 3x plus 2 all over x squared minus 16 greater than or equal to 0. So for the first step, we need to rewrite our rational inequality in a standard form. So what is standard form? So it is a form of the equation or the inequality wherein the right hand side is equals to 0. So since our rational inequality is greater than or equal to 0, so this is already in standard form. So let's just rewrite it. We have x squared plus 3x plus 2 all over x squared minus 16 greater than or equals to 0. For the second step, factor all the polynomials in the rational inequality. So this numerator and denominator should be factored out. So what is the factor of this polynomial in our numerator? So how to get the factor of x squared plus 3x plus 2? In getting the factors, we can take a look at the last term or the constant term. What is the factor of 2? So we have a specific factor. We have 2 and 1. How can we know what is the sign of our factors? So take a look at the second term. We have plus 3x here. So if we combine these two, it should be equals to 3x or 3. So the sign of this is positive. Both positive because 2 plus 1 is equals to 3x. So to 3. So we have factors for our numerator, x plus 2 and x plus 1. What about our denominator, which is x squared minus 16? This is in a form of binomial square. So the factor of this negative 16 is 4 times 4. So we have x 4 here and x 4 here. Since it's negative, so one of this is negative. So this is greater than again to 0. For the third step, using the factors we have in the rational inequality, determine the critical points. How can we determine it? So that critical points will be divided or will divide the number line to generate the intervals of the possible solutions. So we have 4 factors here. So let's try to get the critical points. So we have x plus 2 equals to 0. So your x here will be x is equals to, transposing 2 to the other side, we have negative 2. Next, we have x plus 1 so equals to 0. We have x equals to positive 1, transpose it to the right side, we have negative 1. Another, we have x plus 4 equals to 0. Transposing positive 4 to the other side, we have x equals to negative 4. And last, we have x plus, minus 4 equals to 0. So transposing negative 4 to the right side, we have 4, positive 4. So we have x minus 4. So these key numbers or critical points divide the number line into 5 test intervals. So why 5? We just have 4 critical points here because we include the continuity or the continuous part of your negative and positive side. So we have negative infinity and positive infinity. So we have 5 test intervals. So that is from negative infinity to the nearest to negative infinity is negative 4. So we have negative 4 as your first interval. Second interval, we have from negative 4 to negative 2. So we have negative 4, comma, negative 2. Third interval, we have negative 2 to your negative 1. Negative 1. For the fourth interval, we have negative 1, comma, 4. And last, we have the fifth test interval, which is 4, comma, positive infinity.
So for the fourth step, which is testing the intervals, we have these 5 intervals that we got from step 3. So these are negative infinity, comma, negative 4, negative 4, comma, negative 2, negative 2, comma, negative 1, negative 1, comma, positive 4, and last is positive 4 to positive infinity. First, we need to have our test point. This test point should be part of the interval, the specific interval we have. So first, let's have negative infinity to negative 4. So we can consider negative 5 as your test interval since it's belong to this interval, as test point rather. So now, for the next column, we need to evaluate the factors we have in your numerator and denominator. What is our numerator? So we have x plus 2 multiplied by x plus 1. For our denominator, we have x plus 4 and x minus 4. So let's evaluate our factors. How? By substituting our test point. In here, we're just gonna consider the sign of your factors. Why? Because we need to know what is the quotient, what is the sign of our quotient. So we have negative 5 plus 2 times negative 5 plus 1. So we have here negative 5 plus 2, we have equals to negative 3 times negative 5 plus 1, that is negative 4. So negative times negative, that is positive. So we have positive 12. So in here, the factor for your numerator is positive. Next, for the denominator, we have x plus 4 and x minus 4. Just substitute negative 5. So we have negative 5 plus 4 multiplied by negative 5 minus 4. We have an equivalent of negative 5 plus 4, we have negative 1 times negative 5 minus 4, we have negative 9. So we have positive 9. So again, our factor is positive. For the next interval, let's have negative 4, comma, negative 2. So at this point, we can consider is negative 3. So substitute the negative 3 to your numerator and denominator to evaluate those factors. So let's have negative 3 plus 2 times negative 3 plus 1. So that is equals to negative 3 plus 2, we have negative 1 times negative 3 plus 1, we have negative 2. So negative 1 times negative 2, we have positive 2. So again, this is positive. So next, for the denominator, we have x plus 4 and x minus 4. So we have negative 3 plus 4 times negative 3 minus 4. So we have equals to negative 3 plus 4, we have positive 1. Negative 3 minus 4, we have negative 7. That is equals to negative 7. So this is, this time, negative. Next, for our next interval, the testing interval negative 2, negative 1, we can consider negative 1.5. This is in between this interval. So we have negative 1.5 plus 2, then negative 1.5 plus 1. So this is equals to negative 1.5 plus 2, we have 0.5 times negative 1.5 plus 1, we have negative 0.5. So positive 0.5 multiplied by negative 0.5. So we have negative here, then we have a value of 0.25. Next, for the denominator, we have to evaluate negative 1.5 plus 4 multiplied by negative 1.5 minus 4. So this is equals to negative 1.5 plus 4. So we have 2.5 here multiplied by negative 1.5 minus 4. This is negative 5.5. So when we multiply positive 2.5 times negative 5.5, we have negative value. So negative 13.75. Another testing intervals, we have negative 1 to positive 4. So we can use 0 here. So 0 plus 2 and 0 plus 1. So this is equals to 2 times 1. So this is equals to positive 2. So positive again. Here. Next we have 0 plus 4, then 0 minus 4. This is equals to 0 plus 4, that is 4, then 0 minus 4, that is negative 4. So multiplying 4 times negative 4, we have negative 16. So negative. And for the last, we have positive 4 to positive infinity. So we can use 5 as your testing interval. So 5 plus 2, then 5 plus 1. So we have here 7 times 6. So we have positive 42. Next, we have 5 plus 4, then 5 minus 4. So this is equals to 9 times positive 1. So we have positive 9. For the last column, we need to get the sign of your quotient, numerator divided by denominator. So what is the sign of the quotient of these two? So positive divided by positive, so that is positive. Next, positive divided by negative, so this is negative. Next one, we have negative divided by negative, so that is positive. So for the fourth, we have positive. This is positive. Positive 2 divided by negative 16. This is negative. And last, we have positive divided by positive. So this is positive.
After testing the intervals, we need to consider only the intervals that will satisfy the rational equation. The answer will depend to the inequality symbol. So, an inequality symbol we have here is greater than or equal to 0. That means the sign that must be considered is positive, the sign of the quotient. So, after testing the intervals of the rational inequality, we have given x squared plus 3x plus 2 over x squared minus 16 greater than or equal to 0. The intervals that satisfy the rational inequality or the intervals with positive sign of the quotient is are negative infinity to negative 4 and negative 2 to negative 1, and last we have positive 4 to positive infinity. So for the last step, we need to determine if the critical points we have here are included in the solution set. So first, let us try x is equals to negative 4. So this first critical point. How can we do that? We can substitute this value to our rational inequality. And if it satisfies this rational inequality, we can determine if this is part of the interval, part of the solution set rather. So we have x squared plus 3x plus 2 all over x squared minus 16 greater than or equals to 0. So we have negative 4 squared plus 3 times negative 4 plus 2 all over negative 4 squared minus 16 greater than or equals to 0. So negative 4 squared we have 16 plus 3 times negative 4 we have negative 12 plus 2 all over negative 4 squared we have 16 minus 16 we have greater than equals to 0. So 16 plus minus 12 is positive 4 plus 2 that is 6. 16 minus 16 that is 0. So this is greater than 0. So note that the left hand side of the inequality is 6 over 0, which is undefined. So this value is undefined. That means negative 4 is not a solution. For the second critical point, we have x equals to negative 2. So let's substitute x negative 2 equals to negative 2 to our irrational inequality. We have x squared plus 3x plus 2 all over x squared minus 16 greater than or equals to 0. So we have negative 2 squared plus 3 times negative 2 plus 2 all over negative 2 squared minus 16 greater than or equals to 0. So we have negative 2 squared, we have 4 plus 3 times negative 2, that is negative 6 plus 2 all over negative 2 squared, we have 4 minus 16 then greater than or equals to 0. So we have 4 minus 6, that is 2 plus 2, that is 0. 4 minus 16 is equals to negative 12, greater than or equals to 0. So this one, 0 divided negative 12 is equals to 0, greater than or equals to 0. Meaning, your x equals to negative 2 is a part of your solution. For the third critical point, which is negative 1, so let's substitute x equals to negative 1 to our irrational inequality. So we have x squared plus 3x plus 2 all over x squared minus 16 greater than or equals to 0. So substituting negative 1 to our x, negative 1 squared plus 3 times negative 1 plus 2 all over negative 1 squared minus 16 greater than or equals to 0. So negative 1 raised to 2 or squared, we have positive 1 plus 3 times negative 1, we have negative 3 plus 2 all over Negative 1 squared, we have 1 minus 16. So, greater than or equals to 0. So, we have 1 minus 3. We have negative 2. Plus 2, we have 0. All over 1 minus 16, which is equals to negative 15. Greater than or equals to 0. So, 0 divide negative 15 is equals to 0. Greater than or equals to 0. So, this is correct. That means, negative 1 is part of your solution. For the last critical points, we have 4. So, we have x equals to 4. Substitute it to our rational inequality again. So, we have x squared plus 3x plus 2 over x squared minus 16 greater than or equals to 0. So, we have 4 squared plus 3 times 4 plus 2 all over 4 squared minus 16 greater than or equals to 0. So, 4 squared is equals to 16 plus 3 times 4, we have 12 plus 2 all over 4 squared is equals to 16 minus 16 greater than or equals to 0. So, we have 16 plus 12, that is 28 plus 2 equals to 30. 16 minus 16 is equals to 0. Greater than or equals to 0. So, this 30 over 0 is undefined. Meaning that x is equals to 4 is not part of your solution. Therefore, the solution set is negative infinity, comma, negative 4, union of negative 2, comma, negative 1, union of positive 4, comma, positive infinity. So, the notation, parenthesis, open and close parentheses, indicates that the critical points are not part of the solution. While this symbol, the bracket symbol, means that these critical points, the negative 2 and negative 1, are part of your solutions. That's it for the example 1.